This got me all excited. So when you get like hybrid chicken or hybrid corn or hybrid tomatoes, you don't get GMOs, right? Genetically modified organisms. What you get is F1 generation or more complex crossbreeding crosses, especially in poultry. So and when you use those animals or plants, you actually don't get the same result as using hybrid animals or hybrid plants. So how do you get the F1 generation? What do you get? You get this, right? So would this be an F1? Right. Well, let's use white chalk for this. So you get this from a breeding company or a genetics company, and then you try to reproduce these animals or produce these plants from the seeds again. You get the seeds and produce these. And what do you get? F2 generation, right? So you cross the animals among themselves, like the chicken, or you get the seeds for the plants and stuff like that. And then what are you going to get? You're going to get this situation, right? So the probability is 1 over 4 this, and 1 over 4 this, and 1 over 2 is this, right? So half of the time, or with the 50% probability, you're going to get the same thing as the F1 generation. So this is, in theory, if you look at it simply, if you look at it too simply, you should get the same thing. Same alleles, same genes, same combination as the F1 generation. So if you have like 100 animals, you should, like 50 of them should be the same as the source, or is the same as the hybrid animals. But you don't get that. You don't even get one of them correct, right? You don't even get one of them like the hybrid animal here. Is it because they're GMO, genetically modified organisms? No. I've been teaching this for like over 10 years, and I get different responses from students. And one of them said, okay, as soon as the class is finished, well, let me go now, and I'm going to apply to a bank for a loan, and I'm going to start producing these animals, and I'm going to get 50%. That's enough for me. And I'm going to raise chickens and things like that. We don't have to pay money to other countries and things like that. But I said, well, stay until the end of the class, and then, first learn what's going on, and then go try to learn things like that. But so what's going on? In theory, you should be able to get 50%, but you're not getting 50%. You're getting nil, maybe 1 in 1,000 or something. So what's going on? What's happening here? Not here, but in hybrid chickens. How come you're not, when you're crossing chickens, how come you're not getting the same performance? Like if you're getting 2 kilograms of chicken in 40 days, you're not getting the same thing. For tomatoes or corn, things like that, or other hybrid living things, you're not getting the same deal that you get from the breeding companies. So what's going on is that you don't have just one gene. You have multiple genes affecting a trait. Growth rate in a tomato, or in a corn, or in chickens, right? Or average daily gain in chicks, right? Or feed efficiency in poultry. So you have multiple traits, and these traits are quantitative traits affected by many genes, not just one A gene, but you have many genes like this one. Right? Could be up to 30 or 40, or could be 10, 15, depending on the trait. You have multiple genes affecting that trait. So, if you wanted to do this, right, how would you do it? Let's try to get this. Ready? let's say you have 1, 2, 3, 4, 5, right? So, like I said, it could be like 30, or 40, or 20, or something like that. You get a hybrid animal, so it's more likely that all of these are in a heterozygous state. So all these alleles, you have heterozygous alleles, heterozygous state. And then what you are doing is crossing this with the same animal. I mean, not the same animal, but an animal within the herd that is just like this one. And you want to get this thing, like this whole thing, once again, is a progeny, so that you get the same performance, right? So you want to get this capital A and little a again, and you don't want this like both capital A or both little a or anything like that. And you want to get capital B and little b. You want to get the same thing for this, and then this goes here, right? So what's the probability that you're going to get capital A and little a here when you do this cross?
50%.
It's, what is it?
50%.
Right, it's 1 over 2, right? What's the probability that you're going to get capital B and little b? Again, 1 over 2. What's the probability that you're going to get capital A, little a, and capital B, little b?
1 over 4.
1 over 4. You multiply this using the rule of multiplication that we saw earlier, right? So you want this and this. This comes down to 1 over 4. And then you want this one also. So you multiply it by 1 over 2, so it comes to 1 over 8. And then this one, 1 over 2. Right? Goes on like this. So 2, 4, 8, 16, 32, it's already 1 over 32. Right? And if you go like 10 or 30, it's going to be like, it's going to be more than 1 billion. So 1 in a billion animal is going to be just like what you got from the breeding company. So that's why you're not getting the same animal when you cross these animals, or you're not getting the same plant when you take the seeds or plant it and things like that. Because you are trying to create this combination again from these hybrid animals. Instead of doing this, breeding companies have the purebred animals, let's say capital A, capital B, capital C, capital D, and then little a, little b, little c. I'm simplifying it so you'll understand, but they're basically having purebreds, and they have breeding companies, grandparent stocks and parent stocks, and they have multiple crosses just to get you this hybrid animal or the hybrid plant or whatever. And for chicken companies, there are like major companies, like 3 companies in US and 1 company in Holland, and things like that. So they consolidate companies to get large enough so that they can spend enough money on this research. Now what they're researching is genomics, so that they will get better hybrids. So they are looking at the genes to get better efficiency, better oxygen consumption in the blood and things like that, as opposed to getting GMOs and things like that. No chicken company, as far as I know, is spending any money on GMOs, but they are looking at genomic selection and things like that. So that's why you're not getting the same animal when you cross the animals you got from the breeding company. Okay? And the probability that you will get the same animal is very low, like 1 in a billion low. Thank you for listening.